So lesson number 6 looks at solving quadratic inequalities. We're going to solve these graphically and algebraically, and when we look at them algebraically, we are going to look at 2 different types of ways of solving algebraically. By case analysis, which is this lesson, and then the next lesson is sign analysis. So these inequalities differ a little bit from what we were looking at the other day because they're not, I don't have a y variable. This is, the quadratic equation is less than 0, or it's greater than 0. So again, we have a range of x values. So instead of having an x and a y value, that would be my solution, I have a range of x values that would make this equation true. X values that if I substituted it in, the answer would be less than 0. So if we look at a graph, x squared plus 2x minus 8 is greater than 0, and x squared plus 2x minus 8 is less than 0, are quadratic inequalities where the solutions can be determined from the graph associated with the quadratic x squared plus 2x minus 8. So if I look at this graph, I have 2 intercepts of the graph that are at -4 and +2. Okay? Now, if I look at this part of the graph, everything above the x-axis, this would represent all of the possible solutions that would solve the inequality greater than 0, because everything here, the y value, is greater than 0. So if I put x equals 3 into this equation, I get a number that's bigger than 0. If I put in a value that's just a little bit greater than 2, it will be greater than 0. If I put in a value that is -6, I will get a positive answer. So how I could express that is I could say that I could use all of the values that are greater than 2. Anything that's bigger than 2 is going to result in this inequality being greater than 0. So the solution could be that x can be greater than 2. The other part is this part in here. This part of the graph is also greater than 0. And these are all the values from -4 and less. So in addition to x value being greater than 2, it can also be less than -4. Those would be 2 possible solutions for that inequality. Then what I have is I have the coordinates below the x-axis. So this part in here, this is the part of the graph where the solution is going to be less than 0. So any of these values that I pick along this line, the answer is going to be less than 0. Well, that's all the values in between -4 and 2. So the way that I can write that is I can write it as x has to be less than 2, but greater than -4. And it's not equal to either one because the inequality is not equal to 0. Had the inequality been equal to 0, I could make each of these then equal to that value. Because if I put 2 into this equation, I get 0. And in this case, 0 is not less than 0. 0 is not greater than 0. It's equal to. So without that equal to bar underneath the inequality, my solutions can't include those values. If I was to use a number line, which kind of is what I did here, the only difference being on my number line, these intercepts would have to be open circles because it does not include the value of 2. It does not include the value of -4. So this is what it would look like for values greater than 0, and for the values less than 0, it would be that number line. Okay? So it is an expectation that you be able to both express it graphically on a number line like this, or being able to express it in kind of a notation form. So we'll look at another graphing example. Use the graph of the function f of x equals 12 plus 4x minus x squared to solve the inequality 12 plus 4x minus x squared is greater than or equal to 0. So what we would do is we would graph this function. So I'm going to give you a couple of minutes. I want you to graph the function and identify where the x-intercepts are. What are the zeros of this function? Okay, so what are the zeros of this quadratic? Okay, so -2, +6. Where does it cross the y-axis? 12. At 12. And does it open up or down?
Down.
Down. So my quadratic looks something like that. So that's this line here is the line y equals 12 plus 4x minus x squared. What I want from this graph is I want the inequality where this is greater than or equal to 0. So the part of the graph that is greater than or equal to 0, is it above or below the x-axis? It's above. So that's this section in here, which goes between the 2 points. Are -2 and 6 part of the solution? Yes. And why? Because the inequality can equal 0. So graphically, if I was to graph this on a number line, that's what my number line looks like. So on a number line, it would go from -2 to +6 and close circles on each with a line joining them. If I had to express this by notation, let's put the notation right beside it. If I wanted to express this using notation, it would be the values that are less than 6 or equal to 6, but greater than -2. So between -2 and +6. If I look at question C, C asks you to state the solution to the inequality that is less than or equal to 0. So less than or equal to 0, is that above or below? Below. So that's the part of the graph that's below. So that's all of these values, which start at -2 and get smaller. So how would I write that? X would be what?
Less than -2.
Okay, and can it equal -2? Yes. Okay. And then this part of the graph is all the values in that direction. So how would I write that as an inequality?
Greater than or equal to 6.
Right. When the inequalities are split like that, we write them separately. So it could be one or the other. When they're in between, then we write them together. So we don't put this together in a form where, it just gets messed up when we try to do it that way. Because, we won't even write it down. It's just messed up. So what I would like you to practice with, and this is all graphing stuff. So question number 2, question number 3, A, C, and E, and question number 4. And then we'll do the algebraic approach.
Yeah, that's what
Okay, so let's look at this next part algebraically. Colin's looking at the inequality x squared plus 2x minus 8 from class example number 1. And he's wondering whether or not he could solve this without having to draw a graph. So because it's a quadratic, we start off by factoring it and identifying what the zeros are. So Colin factors this and gets x plus 4 times x minus 2 is greater than 0. So then he says that x plus 4 has to be greater than 0 and x minus 2 has to be greater than 0. Gives him two solutions that x is greater than -4 and x is greater than 2. Well, x can't be greater than both of them. So from there, he has to reject the greater than -4 because there's going to be values between -4 and 2 that don't fit this part in here. For example, if I use 0, which fits here. 0 plus 4 is greater than 0. That works. But when I put 0 into this one, it doesn't work. So I have to limit it to this part in here, to the x is greater than 2. Now, when he looks at the actual graph and looks at the solution that we got when we did class example number 1, he only has half the solution. He's missing part of it. And where he's missing the part of it is right here. It's between line 2 and 3. In line 2, the inequality has to be greater than 0. So Colin's conclusion was that both factors have to be greater than 0. Positive and positive is going to give me a positive. Is that the only way that I can get a positive answer? Is if I multiply two positive values? How else can I get a positive answer? A negative and a negative. So if I looked at letting x plus 4 be less than 0, and let x minus 2 also be less than 0, I would also get a positive answer. So the description for this is if both quantities are negative, the product would be positive. Okay? So if we look at determining the complete solution of the inequality, I have that x plus 4 is less than 0. So I solve for x, and I get that x is less than negative 4. And I have x minus 2 is less than 0. So I have x is less than 2. Now again, if I think of this as being on a number line, I have 2 and negative 4. So I have that the solutions have to be less than 2 and less than negative 4. Well, it can't be both. So which one do I have to reject this time? The 2. Because I can't have this part in here. The stuff between 2 and negative 4 would not solve or make this part of the inequality true. This is what is known as a case analysis. So I have to look at two possible cases. So if we look at the next example, we'll try walking through this one and then we'll kind of look at the flow chart or the explanation. So if we solve the inequality x squared minus x minus 20 is less than or equal to 0 by an algebraic process, what would be our first step? Factor it. So two numbers that multiply to negative 20 and add to positive, or sorry, add to negative 1.
Negative 5 and 4.
Negative 5 and 4. Okay? So when I look at this inequality, the inequality can be less than or equal to 0. So what does that tell me about the product? If I multiply the two factors, what type of an answer do I have to get in order for this to be less than 0? It has to be negative. Okay? How do I get a negative answer? How do I take a product and make it negative? One has to be positive, one has to be negative. So I have to have a positive and a negative, or a negative and a positive. Those are my two cases. So my first case is that x minus 5 is positive and x plus 4 is negative, and they can be equal to 0. And my other case is that x minus 5 is negative and x plus 4 is positive. So now we're going to go through and we're going to solve these 4 inequalities and see what we get. So I get x is greater than or equal to 5, x is less than or equal to negative 4, have x is less than or equal to 5, and x is greater than or equal to -4. Now, from here, it might help to actually graph our solutions to see what they would look like. So if I looked at this, I have -4 and I have 5. X is greater than 5. X is less than -4. Are there any common solutions between these two? No, so does this work? This doesn't work at all because I'm not going to be able to find an x value that makes this true. Because if I pick, let's say I pick +6, I get 6 minus 5, which is 1. I get 6 plus 4, which is 10. I get 2 positive values, which gives me greater than 0. If I picked a number that was less than -4, let's say -3, -3 minus 5 gives me a -8. Or sorry, not -3, it would have to be like a -5. There we go. -5 minus 5 would be a -10. -5 plus 4 would be a -1, the product of which would give me a positive answer. So this completely gets rejected because the solution does not work. Now if I look at this and graph it, I have all the values that are less than 5 and all the values that are greater than -4. Do I have some overlap in there? Yeah, I have all the values in between. There's my solution. X is between -4 and +5. So when we go to solve these inequalities using a case analysis, which is an algebraic system, we start off by determining what the zeros are. Once we have the zeros, once we have our factors, then we have to consider if the product is greater than 0 or the product is less than 0. When the product is greater than 0, I have the first case where both factors have to be positive, and then I have the second case where both factors have to be negative. And then if it's less than 0, I have where the first factor is positive, the second one is negative, and then I also have to consider the second case where the first factor could be negative and the second one could be positive. Okay? And sometimes when you're doing this, there might be no solution, such as right in here. There was no solution to that part of the equation. So we have one last example to go through. Use case analysis to solve the inequality 5 minus 14x minus 3x squared. So if we were to factor this, how would I get the 5?
5 and 1.
5 and 1. How am I going to get the 3x squared? 3 and 1. And to get it a negative 3x squared, one's going to have to be positive, one's going to have to be negative. What I need to figure out now is where to put the 3 and the 1 so that I get negative 14 in the middle.
Make it a -3 across again.
So there's my negative 3x squared, and then I get a negative 15x and a positive 1x. And this has to be greater than or equal to 0. Meaning that the product has to be positive. So if the product has to be positive, my case 1 is that both factors are positive. So 5 plus x is greater than or equal to 0, and 1 minus 3x is greater than or equal to 0. So then I get x is greater than what? -5. And x is greater than or equal to, or sorry, this one here Because this is a minus 3x, I'm going to put it to the other side of the equation. Because then I don't have to think about that rule where I have to reverse the inequality. I keep my x positive. Then divide by 3. And I get that x has to be less than 1/3. So if I was to graph that, I have x is greater than or equal to -5. So that's that part of the number line. And then I have that x is less than or equal to 1/3. So less than or equal to 1/3. So the part that overlaps is all of the stuff in the middle. So that's a possible solution, is that x has to be between -5 and 1/3. That's the first case. The second case, I have to look at both factors being negative, because that would also give me a positive product. So I would have that 5 plus x is less than or equal to 0, which means x would be less than or equal to -5. And then 1 minus 3x is less than or equal to 0. I move the 3x over and divide by 3, and I get that x has to be greater than or equal to 1/3. And when I show this on a number line, x has to be less than or equal to -5, and x has to be x has to be greater than or equal to 1/3. Do I have any overlap? No, so this one doesn't have a possible solution, so I reject this one. And my solution becomes that. So I want to add question 5, A and F, and then number 7.